Hello everyone, my name is Anil Chan and today I am going to present a comprehensive review of remote sensing for wetland classification. The author is Madhavi et al. 2018 and my presentation goes like this. First of all, we need to know what the wetland is. Wetland is a transitional land between terrestrial and aquatic system. It serves as a habitat for both aquatic and terrestrial species. According to the report, it covers 7 million kilometers square of the Earth's area. Wetlands have a very benefits to us, to nature, and to everyone. It they serve as a kidney of the nature. We all knows how kidney is important and how it acts on our body. It does same to the nature. They are the indicator of environmental health. They help in water purification. They help in the conservation of air, water. Wetlands have a recreational and aesthetic values too. They help to support the local economy, like they can earn from the grazing, they can earn from the fisheries, which helps to support to improve their livelihood. Wetland is lost in different ways. The main one is transformation of land to agricultural and urbanization area, and another reason for this is groundwater extraction. Nowadays we are extracting more water than we need. And other reasons for wetland loss are eutrophication, salinization, pollution, climate change. And according to the report, 54 to 57% of the wetland are being lost or converted in 21st and 20th century. And if we see here, survey of Bay of Fundy, it shows that 85% of salt marsh habitat they are drained or dragged by the silted riparians. And if we go through the classification of the wetland, we have two different systems. One is Canadian Wetland Classification System, that is CWS, and another one is Coordinate Classification System, that is CWS. If we move to the wetland classification method, we have two different methods for wetland classification. What is traditional method for wetland classification? In here, the ecologist or a field worker, they directly go in a field and they just identify the vegetative characters of the wetland and describe the wetland classification in different types. In this one is very primitive one, very old one. It is very costly and it is more time consuming. As we know, most of the wetlands are in the remote areas where we cannot access through due to its topography, due to its ground cover, due to its hydrological cycle. This one makes it more difficult to do, but it is very effective for large management scale. In this traditional wetland classification, CWS and CWCS apply both vegetation characters for classification of wetland. A second one is remote based wetland classification system. In this one, if we use any earth data like satellite imagery, aerial imagery to classify the wetland, then it is called remote sensing wetland classification. It is more costly effective, time consuming, and it is more accessible. It helps to classify the wetland in a very difficult topography where we can't go, because we can get a satellite image and we can directly classify the wetland. It's very easy. And the next advantage is the data we have collected from observations like aerial image, we can directly put it in a GIS, that is Geographical Information System. And if we put on a GIS, then we can directly map the vegetation of that wetland. And we all know that how GIS is important and how effective it is in management and developing plants. And in the figure, if you see, we have 5 different wetlands located in New Newfoundland, Canada. First one is a bog. As we see here, this one is dominated by the sphagnum moss species, and second one is the fen, and fen is dominated by the gramineid species along with the brown mosses, and third one is here is a swamp. It is dominated by the woody vegetation. We can see here the woody vegetations growing there along with the bushes. And fourth one is the marsh. Sometimes the water is collected in some places and it is dominated by the shrubs and forbs and small emergent plant. Then it is called the marsh wasteland. And fifth one is shallow water. If you see here, if you have less than 25% of emergent plant species on a water body, then it is called shallow water wetland system. If we move on types of remote sensing based wetland classification using different resources, then first one is the aerial imagery. In this one, if we interpret the aerial images and classify the wetland system, then it is called aerial imagery. Aerial imagery have very high spatial resolution, which makes it very unique than satellite imagery, because it can recognize a small and narrow wetlands too. That's why it is helpful in detailed mapping of the wetland. It is more expensive than spaceborne imagery, so it is less used by the ecologists to make a plan or to just see how it is functionally good. And second one is SAR imagery. SAR imagery is very widely used by many ecologists nowadays, because it can be possible in any weather condition, because they can easily penetrate through the clouds. That makes it more unique. And the SAR sensors, they can easily detect the calm water bodies located down the vegetation cover. That means we can get more reliable data, more accurate data of the vegetation cover, which makes it more effective than aerial imagery. Now if we move on, next one we have multispectral optical imagery. Optical imagery has very limitations because they give less information about the vegetative characters, physical characters. So if we use multispectral optical imagery to analyze the spectral characteristics of the wetland, we can get more accurate data. Like shortwave infrared band is helpful for moisture characteristics. We can get different moisture characteristics of the ground level vegetation. And likewise thermal infrared bands, they are helpful for the land surface temperature. We can get the land surface temperature of different wetlands through them. And next one is other resources. In other resources we have 4 different resources. Like first one is digital elevation model, we call it DEM. In this one is useful for distinguishing the different wetland classes. We can classify the wetland in different according to the different characters. In this one, extracted topographic features, they help in the location and distribution of wetland. Second one is LiDAR data. In this one, the extraction of topographical information and structural clues helps to give more accuracy. In the digital DEM model, it is that it's only give the location and distribution of wetland, but this LiDAR data gives the structural clues too, where it is located along with how it looks like. So this one is more effective than DEM. Like if you see here, LiDAR data combined with the ICNOS imagery, it gives 75% accuracy. Because if we have more accuracy, then we can build a better plan, better wetland classification plan. We can do a better classification which gives us more effective results. And third one is hyperspectral data. High spectral resolution is the main reason for this hyperspectral data, because high spectral resolution helps in detection of the variation between different vegetation species. These high spectral resolution helps to identify the vegetation species of different characters, which helps in classifying the wetland. And fourth one is unmanned aerial vehicle. We can call it UAV data. Nowadays it is recently applied in most of the landscapes, because it have more benefits over typical aerial images, because typical aerial imagery have less advantage because it is more expensive. It cannot penetrate through the clouds, but UAV data, it is capable of acquiring image below the cloud cover. Then it is more effective than the aerial imagery. Nowadays ecologists are using this one frequently to identify, to classify the wetlands. If we move on next one, now we have multi-source wetland classification. In this one, if we are using multiple sources of remote sensing and combinedly using it to classify a wetland, then it is called multi-source wetland classification. This one is very useful in monitoring the wetland classification, and we have to manage this wetland classification. Then it is very important. It is very helpful in distinguishing the vegetation types. If you have different vegetation types in a wetland, then it is very helpful if we use multiple sources. The main common one is use fusion of SAR data with optical data. This one is very common, multiple source wetland classification use, because it gives us more accuracy. It is more reliable than others. And next one is multi-temporal versus single data wetland classification. As we see, nature causes rain, vegetation, hydrological cycle changes over time to time. If we use single data, like if we use a single data of now, and after 1 or 2 years, if we see this wetland, it will be obviously changed. So single data can't be more accurate than multiple temporal, because in multiple temporal we use the data of different dates. Like if we use the data of different days from 1 month to month up to the 3 years, then collectively if we see, we can get a final wetland view, which will increase the accuracy of our wetland classification, what it look like now. And next one is object based versus pixel based wetland classification. Pixel based analyze the value of each pixel to pixel wide, but it has some limitations. So object based image analysis, we can call it OBIA, have more it have more benefits than pixel based, because object based image analysis is more ecologically important in interpretation of the wetlands. It helps in large volume of the multiple sources data. If we are using multiple sources of data, then we will use the object based image analysis, and it gives the more accuracy too. And if we move on, then summary of this one is satellite remote sensing is best for global level for updating and monitoring the wetland inventories. Centralized one is best one because traditional one is like primitive one. We can go to that age because the technology have changed a lot in those years. Then we don't have to give more effort, we don't have to waste money, because if we are doing the traditional one, we will waste a lot of money. But if we use that same money in developing more and more technologies, then we will get more accuracy and we will get a better result in future. So satellite remote sensing is best one for wetland inventories. Second one is SAR imagery. It is best for shrubby or forested wetland or herbaceous plant, because SAR imagery, they can penetrate through the clouds. That means we can do it in any weather conditions. Like forested wetlands or herbaceous wetlands, they have a high vegetation cover, so we cannot get the information of the ground level. But SAR sensors, they are very unique that they can even identify the calm water or slow moving bodies. They can give more accurate and high information about the ground level situation, which makes it more unique, more acceptable, and more widely used for the shrubby wetlands, herbaceous wetland, or forested wetlands. And next one is multi-temporal and multi-source classification are more widely used by ecologists for the wetland classification, because it keeps us more accurate. If you are using the more sources, then we are minimizing our defaults. That means we will obviously increase our accuracy. We will get more data, which helps in the classification, which helps to get a better wetland classification. And last one is remote sensing, has to improve all of the our financial problems, because remote sensing will obviously be cost effective. It will be time saving, because at last we have to save the time, because the nature is changing day by day and we are losing the wetland species and wetlands day by day, because we need to save it now. So if we do the remote sensing for wetland classification, we can save time, money, everything. So we can give this time on saving our nature, saving our wetlands in the future. Because if we have to do repeatedly a wetland, if we have to do classification of repeatedly of, as example of a Lismore, now we just go through and travel all of the forests here and we just identified. And if we have to do after 2 years, then again we have to go, we have to lost a lot of time. But if we are using remote sensing, we can use that data on the next time. We don't have to do it repeated by repeated. We can do it one time and it will be more effective. The last one is thank you to everyone. My presentation ends now. Thank you.